Hey, David here. Black holes are one of the strangest things in the universe. They don't even seem to make sense at all. Where do they come from? And what happens if you fall into one? We'll see that in this video. Now, we know that stars, like our own sun, and the ones we see in the night sky, are huge collections of matter, mostly composed of hydrogen atoms, and these collapsed into their own gravity. Now, in the center of each and one of these, there is a process going on called nuclear fusion, and this transforms hydrogen atoms into helium atoms, and this creates a whole bunch of energy, maintaining a very delicate balance between these two forces: energy in the form of radiation and gravity. And as long as there is fusion in the core, the star will remain its balance. And what happens with stars even more massive than our sun? Well, it's pretty much the same, but the extra mass creates a ton of heat and a ton of pressure, so this helps to create more elements. So it goes from hydrogen to helium to silicon to oxygen, and it ends with iron. Now, the thing about iron is that when the process ends, when the atomic fusion ends and the product is iron, it liberates no energy at all. So it keeps building up in the core of the star. So once it reaches a critical amount, it has no fusion left, so the balance now it's broken. There is a whole lot of gravity and there's too little of the fusion. So the gravity wins this battle and the star implodes. Now, when a star implodes, it means that all of the mass in the core gets suddenly compressed into a tiny point in space. Now, depending on the mass of the star, this can either generate a neutron star, which we can talk in another video, or it generates a black hole, depending on the mass of the star. If it's less massive, it will generate a neutron star. If it's very massive, it will generate a black hole. Now, this is the main difference. Now, when we look at a black hole, we're actually looking at its event horizon. Now, the event horizon is the most outer layer of a black hole. Now, this is a barrier, which if you cross it, you can't go back. You actually have to go faster than the speed of light to go out, which is literally impossible. That's why nothing can escape a black hole, not even light. But what's inside a black hole? What is the whole part of the black hole? We already discussed the black part, which would be the event horizon. But what's the whole? Now, that would be the singularity. Now, the singularity is an infinitesimal small point where all of the mass of the core of the star came to be. Now, because it's a point, it's infinitely dense and has no surface or no area. This seems a bit strange, but keep in mind that we also are not certain about what's inside a black hole. These are just predictions made from various theories. It might be a whole different thing, but overall, we just don't know what's inside. So for the last part of this video, with a little bit of extra lighting, we're going to talk about what would happen if you were to fall into a black hole. Now for this, we're going to talk about two perspectives: an observant, which is watching you fall, and you. So the observant will watch you move slower and slower as the time passes, and also would look at you as if you were turning red. So once you get into the event horizon, you will disappear, because not even light can escape, so they cannot see you. And that's it. So you, on the other hand, will watch the universe in fast forward, as if you were looking into the future, which is pretty odd. And now when you get there, things will not be comfortable, because gravitational forces on the parts that are facing the black hole are actually being pulled with more strength than the parts that are facing away. So you will be literally torn apart. And that's pretty awful. And that will be it. I know that I didn't explain a lot of things about black holes, but these were the basics, the basic aspects, and that. Thank you all so much for watching. I hope you enjoyed, and I'll see you guys soon. Take care. Bye for now.